Right, boys and girls, we'll be simplifying. We've chosen 4 sums out of exercise 8. And we need to remember all our rules of simplifying now. So just to quickly put them all together here, we discussed our rules for exponents last week or earlier this week, and we also discussed our rules for signs. Basically, when do we apply the rule for just adding and subtracting on the number line, or when do we do the multiplication rule and the division rule? So very important that we just remember what is the difference between these rules, because the one would move on the number line and the other one would multiply and divide. So when we work with our rules, we want to not get confused with the rules of simply adding values and subtracting values. Right, let's start with number 32. So I see that I have the distributive law that's going to be applied here. The 7x needs to be multiplied into the bracket, and that's why I say the distributive law. So if we take 7x and we multiply it into the bracket, within our bracket, let's just first check the nature of what's in our bracket. What do we see? We see 3 different terms. Are those terms like? They are not like terms. So let's just always check our bracket first. The content of your bracket, if you can simplify it, then go ahead. But in this case, we can't. So we are going to apply our rule, and we are going to distribute 7x with each term, because this is product. So 7x times x to the power of 4. 7 is the coefficient. I'm multiplying it by 1, as 1 is the coefficient of x to the power of 4. And it's 7. X to the power of, there's a power of 1 here with your 7x, and those powers are added. So it becomes 1 plus 4, which is then the power of 5. Now I go back and I do the second term. I go back to my original 7x, and using the distributive law, I multiply it with minus 2x cubed. And here I get my sign. Very important. I have a positive times the negative. What do I mean? I have a positive times the negative. This sign in front of my 7 is the positive that I'm talking about, and this sign here is the negative. And why do we say we multiply? It's because we're working over this bracket. Okay, so now the positive times the negative becomes a negative. 7 times 2 is 14. And x to the power of 1 times x to the power of 3 becomes x to the power of 4. I go back to my 7x and I multiply it with the third term, the constant. And here I see I have a positive times a positive is a positive. Note how I sort out my sign first, then my coefficient, and then the variable. The variable is the ever-changing little letter, and then the exponents. This is your rule that you will apply with products. So when we do this, we are making sure that we check the sign. Positive 7 times a positive 3 becomes a positive 21. And that's my coefficient. Then the variable, I had a 7x times 3, so I needed 21x, and the 3 did not have any x's, so no need to add the powers there. I am left with unlike terms, so I can't continue further, and that is my final answer. Okay, right, let's try number 33. Number 33 shows us we have a negative 4m in front of the bracket. Bracket means product. I have several terms within my bracket, and the first thing I do is I check, can I simplify anything in my bracket, adding or subtracting them together? No, they're all unlike terms. Let's go ahead and let's apply the distributive law. So minus times the positive, here's my minus, here's my positive, There's a little positive in front of my m. Minus times a positive is equal to a minus. And 4 times 1 is equal to 4. And m to the power of 1 times m to the power of 3 becomes m to the power of 4. I go back to my 4 minus 4m. Minus times a minus now is a plus. 4 minus 2 is 8. And my m to the power of 1 times m to the power of 2 becomes m to the power of 3. And I go back again to my minus 4 because I need to multiply, distributing it into the bracket. Now I have a minus times a minus, and I get a plus. 4 times 4, 16. And what about that m? It's still part of the product. Final answer, unlike terms, and it's also in descending powers of m if you haven't noticed. So we always like to leave our final answers in descending powers of the variable at hand. Right, let's try number 35. Number 35, I have a little bit more intricate powers right here. So here I see a to the power of 2 and b, right? There's the product. Times 3a b squared minus 2a b squared minus 1. Now, what did I say in the beginning? Let's always check if we can perhaps simplify here by adding and subtracting. Do we see a like term? Yes, I see one. I see that my ab squared is creating like terms. So let's just first simplify the bracket because we are allowed to make life a little bit simpler, and we keep that a squared b in front of our bracket. 3ab squared minus 2ab squared is simply a positive 3 minus 2. Okay, we are not multiplying. We are just working on the number line here. Very important to see the difference. So 3ab squared minus 2 of these ab squares gives me 1ab squared. So for the sake of just making it simpler and clarifying it for us, I'm just going to make that little 1 here in highlighter so that you know you still have one of these. You keep your minus 1, that is the constant. Okay, there's our constant, close our bracket, just to make our product simpler. So now I go back to multiplying 1a squared b with 1ab squared. So note, you've got different bases now, right? You have a to the power of 2 and an a to the power of 1. And then you have b to the power of 1 and a b to the power of 2. So we need to treat this with care. Our coefficient remains 1, it's a positive. So I'm just going to leave that imaginary 1 out. But a becomes a to the power of 2 plus 1 is 3. B becomes b to the power of 1 plus 2 is 3. Note, we do not separate this. Common mistake here is that we want to write it like this, as if it's two different terms. No plus or minus separating the terms here, okay? Therefore, it's not the same. It's only product. And now I go back, take that a squared b and multiply it with a minus 1 and a minus a squared b. There's my result. So my final answer, minus a squared b, a cubed b cubed minus a squared b. These are not like terms, so I leave it like that. Great, I trust you all understand. Then let's go to number 36. Number 36 we see, right, I have a bracket and I have a squared minus 3a plus 9 times 2a. Now this looks weird because we're not used to seeing things like that. A monomial. This is a monomial. We're not used to seeing the monomial at the back of the bracket. But there is a law that we learned in first term, and that law states that we are allowed to change the order of things. The commutative law. Commutative law states that we are allowed to say a times b times c is b times a times c it's also CBA. It's all the same thing because the product does not change. So for the purpose of working effectively here without getting confused, I'd like you to move that to A, right there in front of your bracket. Everything else stays exactly the same. We are not changing the nature of what's been given to us, but now it's easy because now I can apply the law of distribution. And I get a positive times a positive is a positive. 2 times 1 is 2. A to the power of 1 times a to the power of 2 becomes a to the power of 3. Go back to the beginning. 2a times. Positive times a negative is a negative. 2 times 3 is 6. A to the power of 1 times a to the power of 1 is a to the power of 2. Go back to the beginning. 2a times the constant. Positive times a positive is a positive. 2 times 9 is 18. And there I go. Final answer. Great. No need to simplify further. They're all unlike terms. Right, now let's look at that number 38. Okay, number 38 has a negative in front of the bracket. And we have another monomial. So we know a monomial is one term. Mono means one. Right, but it looks a little bit confusing here, so I'd like to make it a little bit better in the eye. I can see that negative there, but I can also see this monomial at the end. So let me just rearrange my order. That's all I'm going to do. I'm just going to rearrange the order using my commutative law to make things look a little bit better. And I'm going to keep that negative there, but I'm going to move the minus 5x monomial here. And I'm going to just put this bigger bracket next to it. And now I'm just going to do one more thing just to simplify life a little bit more. I'm going to sort that out. Why am I now allowed to multiply into the bracket when we have learnt a law stating don't multiply into the bracket when the power is raised? So don't misunderstand this. This is a very different thing from this, okay? It's not the same, okay? Here, I have to first sort out my power. The rule is brackets take priority. Powers need to be simplified with a monomial, and then after that, I can multiply that sign in. But here, I have nothing that is going to change the nature of this bracket or this bracket. I simply have product. So I may sort out this sign here. And I'm going to make my life a lot easier by sorting out a minus times a minus just becomes a plus. So I leave it as a 5x then. And that 5x is what I'm going to multiply into my bracket. And I'm going to work a lot better now because now there's no hassle with other things. So let's just check, how are we multiplying 5x into the bracket? Positive times a positive is a positive. 5 times 2 is 10. X to the power of 1 times x to the power of 2 is x to the power of 3. Adding the exponents. Go back to the 5x. Positive times a negative. Negative here is a negative. 5 times 3, 15. X to the power of 1 times x to the power of 1 becomes x to the power of 2. Go back to the 5x and make sure you multiply each term in your bracket with it. And 5 times 1 is a positive. 5x times 1 remains 5x. And 10x cubed minus 15x squared plus 5x is then my final answer. Right. Sometimes we need a little bit of fixing up to make life easier for us. And that's what we said, that we saw now in number 38. Right, and then the last one for the day, let's try number 39. Okay. Number 39 states a minus 2x squared minus, within the bracket, 3x plus 1, and then a separate minus 5x. Note the difference here. I am not looking at something that we saw here. There is a huge difference. Here, we only have bracket, 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 product. But here, we have product with that negative that will be multiplied into our bracket, but we have a separation of terms because plus and minus signs separate terms. So that minus 5x may not be moved around. It is a separate term. What we do need to first sort out is this right here. So we'll be doing that first. Very important here. Okay, so now let's first multiply that minus sign in and we'll get negative 2x squared, positive 3x, negative 1, and I keep my minus 5 as it is because nothing has changed. Now I go back to seeing which terms are like terms. You may use your little snake in order to divide your terms. If you like to do that, still carry on with it. And let's look at our like terms. I see a positive 3x and I see a minus 5x. And bingo, this is where we get confused once again. Just to clarify the difference, we are not multiplying 3x with that minus 5x, okay? That is not the case here. What we are doing is we are simply adding. We have a positive 3x. We have positive 3x's and we are subtracting 5, which means we are moving to the left. We are getting more negative. Please make sure you look at the difference here because it's so important. And I'm going to just write this final answer in black. And we can then say in descending orders of x minus 2x squared. And I'm left with a negative 5x plus 3x, which will give me a negative 2x. I have not got enough positive x's to make the minus 5x positive. I'm left with a negative 2x and a negative 1, and that is my answer. So a lot of theory that is discussed here. We need to look very carefully, not to get confused by our typical things that cause us to misunderstand it.